Hi everyone, today we're going to be learning trigonometry, how to convert radians to degrees, degrees to radians, and evaluating trig functions. You should already have a background knowledge on unit circles because you do learn it in geometry, algebra 2, and in pre-calculus. This is a course intended for 12th graders, seniors. This is when I took trigonometry when I was in high school. Just in case we need a refresher on the unit circle, the outer values over here are all radians. The values inside of the circle are the degrees. We're going to need the key values here in the bottom left-hand corner for when we are evaluating the functions. So I would say if you don't have it written down, go ahead and write it down now just so you can go ahead and remember the values. And in case you forgot what the trig functions are, it is sine, cosine, and tangent. We're going to go ahead and get started. First, we are going to convert from degrees to radians. I have a formula provided in the top right-hand corner, which is degrees times pi all over 180 degrees. That is because the degrees will cancel out from the top and the bottom, so you are left with pi, and the number that we're obviously multiplying by to get our answer. In case you don't have a calculator right now, I would suggest going to grab one just because sometimes when we are multiplying, the values can get a little bit large, which we don't want to do mental math all the time. So just in case, go ahead and grab a calculator now. We're going to go ahead and continue with the lesson. So we're going to have 45 degrees times pi all over 180 degrees, which is provided in our formula. The degrees do cancel out, so we are left with 45 pi all over 180. We just multiplied straight across. You can divide by 45 on the top and the bottom to simplify, which will be left with pi all over 4. If you want to go ahead and double check if the work is correct, you can see in the first quadrant on the unit circle, 45 degrees is indeed pi over 4. That means our answer is correct. Now we're going to do 150 degrees times pi all over 180 degrees following the formula. Again, the degrees do cancel out, so we're left with 150 pi all over 180, which will actually simplify to 5 pi all over 6, which is indeed 150 degrees based on the unit circle, so that answer is also correct. Okay, now we're going to do convert from radians to degrees. Again, I have the formula provided in the top right-hand corner. The only difference is now instead of it being pi all over 180 when we're multiplying, it's now 180 degrees all over pi. And that is because the radians will be canceling out, which we are left with the degrees on the numerator, which is exactly what we want. Now, we're going to go ahead and get started with the 5 pi over 3. Times, and it's going to be 180 pi all over 180 all over pi. The pi's do cancel out, and as you can see, the 3 and the 18 do have a common factor of 3, which this will be simplified to 60 degrees since it is 3 divided by 18 is 6, and we just add the 0 from the 180. Now we could just multiply the 5 and the 60 straight across, which gets us 300 degrees. Which is also on the unit circle, I believe. It is in the 4th quadrant on the bottom. 5 pi over 3 is indeed 300 degrees. Now we're going to do 9 pi over 4 times, again, the value of 180 degrees all over pi. Now this one we can just multiply straight across, cross-cancel the pi's. So if we multiply straight across, we do get 1,620 degrees all over 4, which do simplify, if you put that into your calculator, into 405 degrees. 405 is above the unit circle limit, which is usually 360. That means it goes around the unit circle one whole time and continues until it gets to 405 degrees. All right, that is converting from radians to degrees. Now we're going to go ahead and be evaluating the following functions. Cosine is, if you can't remember, go ahead and look back at the first slide. But cosine is adjacent all over hypotenuse. And where is 5 pi over 6 located, you may ask? It is in the 2nd quadrant. So now we can go ahead and make our triangle, our 90 degrees there, and the theta is always looking for This is the opposite side. Over here would be considered the adjacent, what we are looking for. The shorter value is always 1/2, and the longer value is square root 3 all over 2, which is a part of the key values that I had listed in the beginning of the video. So if you that was where we would need it. And because the square root 3 over 2 is on the left hand side in the negative direction, it will actually be negative square root 3 over 2, which is our answer because we're looking for the adjacent value for cosine. So that means our answer is negative square root 3 all over 2. And now we're going to go ahead and work on for sine. If you think you know how to solve it, go ahead and pause the video now and continue solving. If you don't, you need a little bit of help, I will help you out. Sine is looking for opposite over hypotenuse, and 7 pi over 4 is in the fourth quadrant. As we can see, it is actually a 45-degree value. That means on both sides for going up and down and left and right, it is going to be the same as square root 2 all over 2. The only difference is now we do have to label which one is negative and positive. Because it is going down in values, that one is the negative. And our sine value is actually looking for, it is opposite over hypotenuse. So the one we pay attention to is the negative square root 2 over 2, which is our answer, negative square root 2 all over 2. Okay, so that is how you evaluate these two trig functions. Now I'm going to have you guys go ahead and try to evaluate on your own. I know we did not do the tangent functions together, but if you need to remember what tangent is, go ahead and go to the first slide to remember what you are looking for. You are, just a quick note, you are going to need to multiply, so just be ready for that. And then you're going to be solving for sine. If you are confused, don't worry, you can always ask questions in class. If not, you can go ahead and continue, and we'll check your work next time we meet. All right, and that is it for this lesson.